In this video, we're going to look at main effects plots and multivary charts, two very powerful tools to enable you to look at the effect of more than one factor at the same time. I'm going to return to the impurities example as an illustration of this. As a reminder, we have impurity content, and that might be affected by which batch it is, whether it's day shift or night shift, or which machine number has been used to produce the product. Here's the main effects and multivary chart button, and I've already populated it with the right settings. You pick as the Y, which is a radio button, meaning you can only pick one at a time, the column that you want to study, and then you pick up to 3 different X's. The X's are the 3 different factors that you're going to use. Each of these can have a maximum of 5 different levels. So for batch we've got 4, A, B, C and D, for example. These charts are forced to be on the same scale, so you can immediately make a direct comparison between them to see which one has the greatest effect. So in this one chart I can immediately say, alright, it looks like machine is having a bigger effect than either batch number or shift. So that's the main benefit of a main effects plot. Scrolling over to the multivary chart, we can see the effect of the factors compared to each other. This is a lot more difficult to interpret because what you're looking at here is whether there's some kind of interaction between the factors. That means that when you change the setting of one factor, the result that you get depends on the setting of another factor. The 3 of them are all shown here. The first thing to look at is the panel variable. That tells you what you're seeing as you move between these 5 different panels, and that is batch. So you can see that same shape that we saw in the main effects plot, that C is a bit higher and A and D are a bit lower. Next thing, you want to look at the red lines, which is the overall average within each panel. This is showing day and night shift, as you can see for the legend here. So there's not a huge effect going on, but there's a much bigger effect from the third factor, which is the one within each of these groups. And you can see we have the brown, green and purple dots. Brown, green and purple, there's the legend there to show you it's the 3 machines. And what jumps out at you here is that that purple dot is significantly higher than the others. Now my tip with using these charts is you always want the one that's the biggest effect to be the one that's the panel variables. It makes it stand out much more easily. So to do that, I'm going to go back to data entry and I'm going to make machine the first position of the 3 columns. So I need to get batch and shift over to the other side of machine. I've done it by copying and pasting because I don't want to delete the formats that are in there, and it's very quick and easy to copy and paste and then just delete what was left behind. Now I'll go back to the main effects and multivary chart. I've got machine already, there's batch and shift. I'm going to get an error message because I've picked too many variables, but that's okay. Now we've got the same thing, but I've put machine into the first position. Scrolling across, and now you can see pretty dramatically that panel variable is showing you that machine gives you higher impurity levels when it's machine number 220. Then the shape of what's inside is now no longer consistent. I don't see the same thing on the top of each of these little individual measurements, and the shape in the red section, which is batch to batch, is not consistent either. Now there's 2 possible interpretations of that. One is that you've just got some random variation, which is reasonable in this case because there's not a lot of data. But if you have a very much larger amount of data, then all the random variation should even out in the end, and so that might be an indication of an interaction, which might mean, for example, that the effect of switching to machine 220 is different depending on whether it's day shift or night shift. As I say, that's not likely to be the case here with limited data, but this is a very good precursor to design of experiments, which is specifically designed to investigate interactions, and I'll cover that in a later video. In the next video, we'll look at a fitted line plot and regression analysis, which is the last of the tools in this sheet that is using variable data.